Hey you guys, so today we are going to be talking about measurements. We're dealing with measurements, we're dealing with things like our metric system, conversions, and a few things like that. So let's get started. So, first of all, when we're talking about measurements, we want our measurements to be both accurate and precise. The best measurements that we can have are both going to be accurate and precise. When you think about accuracy, say that if I say that you got something accurate on a test, we're talking about how correct something is. So, the accuracy is going to be the degree which experimental results agree with the accepted value, or it's going to be how correct the measurement actually is. When we're talking about precision, we're talking about how consistently something happens in the same location, or the degree to which measurements agree with one another. So, how specific is that measurement? Or how consistent is the multiple measurements to each other? So an example that I like to use is I like to use targets. I like to use targets because they are easy to see accuracy and precision. So we all know that the goal of the target is to get it into the bull's eye or the center circle. Okay, so we have four different targets. The first one, all the dots are in the center. So in this one, we would consider this to be precise and accurate. Okay, so it's accurate because it did hit the middle of the bullseye. That was the plan, that was the goal. It's correct, it's in the center of the bullseye. And it is also precise because all of the targets or dots or darts that were thrown actually hit around the same location. So that makes it accurate and it makes it precise. Now, if you look at the one next to it at the top, you can see that the darts did not hit in the center, but they did seem to hit all in the same location. So because of that, we would consider that precise but not accurate. It's not accurate because it did not hit the middle of the bullseye, but it is precise because it all hit in the same location. Now we're looking at the bottom left. So in the bottom left, you can see that they seem to all have hit in the bullseye, but they're not really in the same location. So we would consider that accurate but not precise. And as we look at the last one, as you can see, the darts went all over the place. So this one is neither going to be accurate or precise. Okay. So that is the difference between something being accurate and something being precise. Now, remember, like we said, we want our measurements to be both accurate and precise if we want our best measurements. So we're going to go through one of the questions. So question number 1 reads, if a student knows 85% of the material for the test but makes a 70 on the test, is this measurement accurate, precise, or neither? So the correct answer for that is going to be it's not accurate or precise. And the reason that it's not accurate or precise is because if the student knows 85% of the material and made a 70, that's definitely not accurate because he did not get to 85%. And it's not going to be precise because he was nowhere near the measurement that was predicted. The next one is going to be Miss Joyner's dog, Millie, is known to have weighed 65 pounds. Millie goes to the vet and weighs 3 times and is weighed 3 times at 71 pounds, at 70.5 pounds, and at 71.1 pounds. Are these measurements accurate, precise, or neither? Okay, so Millie went to the vet supposedly weighing 65 pounds, but when she actually got weighed, the measurements were 71, 70.5, and 71.1. So therefore, it was not accurate, but it is definitely precise because all of the measurements were around the same. So that makes it not accurate, but definitely precise. Okay, so another thing is when we're doing labs and we have to collect data, most likely you're going to have to do things to find the average. So when we think about average, it's something that we've done a million times in math or just in general. We know with the average, we're going to add up all the numbers that were given to us and we're going to divide by the numbers that we have, okay? So for example, Callie measures her flowers to be 30 centimeters tall. Jeff measures the flowers to be 45 centimeters tall. Liam measures the height of the plant to be 36 centimeters tall. So what is the plant's average height? Okay, so we want to find the average. So what we're going to do is we're going to add up the numbers that were given to us, and then we're going to divide by the total numbers that we have. So we have 3 numbers, so we add up our 3 numbers and then divide by 3. When we added up our 3 numbers, we got 111, and we're going to divide that by 3, and that is going to give us 37 centimeters. The next thing we're going to do is we're going to talk about our standard unit, okay? So our standard unit, when you think about some standards, you're going to think about what we're going to actually compare to, okay? So what is the comparison for everybody? And the story goes a long time ago that scientists were starting to get confused because they couldn't figure out how to communicate with one another and make trades and do all these other scientific things because there was no set unit. Everybody was using a different type of unit, and it was starting to become very confusing. So they decided to come together and come up with our SI system. And our SI system is the system used by scientists around the world to make measurements. Our SI system actually stands for the International System of Units. And again, this is the units that are used across the world. It's also known as the metric system. Now with this unit or with this type of measurement, it is all going to have a base unit. So every type of measurement is going to have its own base unit, okay? And prefixes are going to be able to be used with these base units. And we know just from English, prefixes are words that come before the words. They're attached to base words, and they have their own meaning. Well, these prefixes are going to be used with the base units, and they are going to be based on multiples of 10. So the metric system is going to be so much easier to manipulate because you're already dealing with multiples of 10. So either you multiply by a multiple of 10 or you're going to do some type of division with the 10. So our units that we have are length, the distance between 2 points, and our length unit is going to be measured in meters. And of course, we're going to use some type of meter stick or ruler. Next, we're going to talk about mass being a unit. Mass is the amount of matter in an object. It's the amount of matter in an object. Mass and weight are not the same thing. They are not the same thing. Mass is going to deal with the amount of stuff something has, and weight is going to deal with gravity. So the unit for mass is going to be kilogram. And we're going to use either a spring scale or some type of digital scale to do the measurement for mass. Next units that we have we're going to have volume. So volume actually is a unit that has been derived. It's not an official SI unit. It comes from a derived unit. So volume is going to be the amount of space occupied by an object. The unit for volume is going to be liters. And we can calculate liters with either some type of graduate cylinder, or we could use the metric equation that we have for liters, which we'll learn at a later time. And then, speaking of time, time is our next unit. So time is going to be the interval between two events that actually occur. The unit for time is going to be seconds. Often, we measure this with a stopwatch. Now, it's very important that you realize when you are measuring volume, do you guys see this little dip right here in the graduate cylinder? This little dip right here is called the meniscus, okay? The meniscus is going to be the curve in the liquid, and that's actually what you are going to measure liquids with. So what you want to do is you want to get at eye level when you're pouring or when you're trying to measure some type of liquid, and you're going to watch for the bend or the curve in the liquid known as the meniscus, and that is how you get your measurement. So if you're looking right here, you can see that the bend is actually on 20 milliliters, and that is the accurate measurement for this particular liquid. So next we have temperature. Temperature is the amount of heat in an object, and the unit of temperature is going to be something called Kelvin. Okay. Kelvin is, I'm assuming, somebody's name who discovered it. I know, get that question a lot. Who is Kelvin? Who is Kelvin? I'm assuming that it's the person who actually discovered the different way to convert the temperature. One thing to know is that the metric system, so in other countries, they actually use Celsius, but the U.S. is the only place that actually uses Fahrenheit. And of course, we know we measure temperature with some type of thermometer. And we'll learn a more scientific kind of definition for Kelvin later on when we start talking about energy the next 9 weeks. But for now, this is how we're going to do temperature. So the temperature does have its own conversions, as you can see. The conversion for Kelvin is going to be K equals degrees Celsius plus 273. So whatever degrees Celsius you have, just add 273 to it, and you are going to get your temperature in Kelvin. And please note that Kelvin does not have a degree sign next to it, okay? It is just the symbol. It's just the K. Next, we have degrees Celsius. So if we wanted to convert to degrees Celsius from Fahrenheit, we would use this second equation. So we have degrees Celsius equals 5/9, and then Fahrenheit times the Fahrenheit minus 32 degrees. So order of operation, of course, tells us to do what is in the parentheses first, and then multiply by what's on the outside. And I'll just tell you this, I personally am not a fan of fractions. Sorry. I'm not a fan of fractions. So I actually convert my fractions into a decimal to make it easier to manipulate. So if you would like to do that, 5/9 actually can convert to 0.55. So instead of using 5/9, if you want to use 0.55, please feel free. If you are happy with fractions and you love them, please feel free to use your fraction. Me, I'm just not a happy camper when it comes to fractions. So I would read this equation as degrees Celsius equals 0.55 times degrees Fahrenheit minus 32. And then I would just do my order of operations from there. The next conversion that we have is going from Celsius to Fahrenheit. So with going from Celsius to Fahrenheit, we have degrees Fahrenheit equals degrees Celsius times 9/5 plus 32. Again, like I said, I am not a fan of fractions. So I would change my 9/5. I would convert that to 1.8 because it roughly gives you a 1.8. So my equation would read degrees Fahrenheit equals degrees Celsius times 1.8 plus 32. I would then just follow my order of operations from that. And then I would just get my answer of what I'm trying to do. So we're going to do an example. So we have this example, Mrs. Smith is going on vacation to Greece for her anniversary, and the weather is predicted to be 27 degrees Celsius. Miss Smith lives in the U.S. though, and doesn't know what to pack for this weather. So we want to help Mrs. Smith determine what she should pack for this weather. So I'm going to give you guys a chance, give you a few minutes to be able to work this equation, and then we'll come back with the answer. All right, so you should have had enough time to work your problem out. So let's go through our steps. So the first thing we're going to do is we're going to always write down what's given to us. We were given degrees Celsius, which was 27 degrees Celsius. And then we need to figure out what problem we need to use. So we're trying to go from Celsius to Fahrenheit. So we want to figure out what Fahrenheit is. So we're going to use our Fahrenheit equation. So the equation that says something equals Fahrenheit, because we want to get to Fahrenheit. Okay. So again, we take our Celsius and we're going to plug in. So it should read 0 degrees Fahrenheit equals 27, which was degrees Celsius that was given to us, times 9/5. If you were doing your decimal, you would say times 1.8 plus 32. Order of operations says do what's in the parentheses first. So that gives us 48.6. And then we will add 32 to it. And we get 80.6 degrees Fahrenheit. Of course, I would probably round that up to 81 because I don't know any meteorologist that goes outside and says it's 80.6 degrees outside today. So I would personally round up. And here is a little time for you to practice. I will give you some time to go through it. If you want to pause this video so you can have time to go through it and then check your answers in a second. Okay, so you should have had time to go over the equation. So for number 1, you should have gotten 73.4 or just 73. For number 2, you should have gotten 8.89, or you could have rounded up to 9. Also, I see, depending on how you put it in the calculator, it might just show up as a whole number of 8. That is also acceptable. I just need to understand that you know the actual steps and you plugged everything in correctly. And then for the last one, you should have gotten 301.3 Kelvin. And those are your 3 equations. In our packet, there is a page where we can stop and we can work through our conversion of our temperatures. So we are going to stop and do that. That is going to be on page 14 in your packet. So if you want to complete page 14, now is the time. And we will talk about it later. All right, the next thing that we're going to talk about are the prefixes. So like I told you earlier, prefixes are going to be the words that are going to be attached to our bases, and prefixes are going to be the multiples of 10 that we have. So starting with our first prefix, or just what the prefix are, we're going to use our prefix to avoid very large and very small numbers. And remembering that they are going to attach to the unit name. So for example, you're going to have a milligram. So milli being the prefix and gram being the base. As you can see, these are our prefixes that we have that we'll go over. These are our units. So mega, that's the unit for mega, kilo, heka, and deca, okay? So you have 1,000, for example, for kilo, you have 1,000 units per 1 kilo, okay? And then down here, we have our other units. We have deci, centi, milli, micro, and nano. So you have 1 unit per every 10 decis, like that. And as we get into it, I hope it'll make a little bit more sense. The last thing we have our base units that's always going to fall in the middle, which are going to be represented by meters, grams, liters, and seconds, depending on what you are actually measuring, okay? So these are our base units in the middle. All right, so what are the steps to actually doing a metric conversion, okay? So the first thing that you want to do is you want to write down the given number and the unit that you have. Then you are going to draw a picket fence. Your fence is going to look just like this. The next thing that you're going to do is you're going to use the chart to fill in the appropriate conversion factors. You're going to make sure the matching units are on opposite sides of the fence to cancel out. Then you're going to multiply your numbers across the top and then multiply your numbers across the bottom. Then divide the top number by the bottom number and you will get your conversion, okay? So of course we're going to do some examples. So I'm going to start with this example, okay? How many meters are there in 48 kilometers, okay? So let's review what our steps were. It says step number 1, we're going to write down our number and we're going to write down our unit, okay? So our number is 48 and our unit is kilometers. That's the first thing that we're going to write down. Then it says we're going to do our picket fence. So you want to draw your picket fence. Okay. So we drew our picket fence. The next thing that we want to do is we want to do our actual conversions. Okay. So we're going to look back at the chart that we just filled in. So one thing that we do know is whatever we're trying to get rid of, we want to put it at the bottom of this fence, okay? We want to put it at the bottom of this fence. So we know that kilometers is going at the bottom because we want our kilometers to cancel out because we're trying to go from kilometers to meters. So going back to kilo, it says that 1 kilo is going to equal 1,000 units. So we're trying to get to meters. So it must mean that for every 1,000 meters that we have, that is going to equal 1 kilometer. Okay. So for every 1,000 meters we have, it's going to equal 1 kilometer. So that's how we write the conversion. Then we want to cancel out like terms. So we're going to cancel out our kilometers, and that is going to leave us just with meters. Then we're going to multiply across, multiply the bottom, divide the two numbers. So if we multiply across, we get 4,800 meters. Multiply across the bottom, we get 1. And we divide, that gives us 48,000 meters. And I'm sorry I misquoted. I didn't mean to say 4,800. I meant to say 48,000 earlier. Okay, so that's one example. Okay. All right, so now we're going to do another example. All right. So I'm going to let you pause the video, and I want to see if you're able to do it, and then come back and check your answer. Okay, so let's check and see what we have. So it says, how many kilograms are there in 45,456 milligrams? So step number 1, write down what was given to us. Step number 2, draw your picket fence. Step number 3, we're going to write our conversions, okay? So first of all, we know we want to get rid of the milligrams, okay? Because that's what we have right here. So we know milligram is going to go on the bottom. All we have to do is figure out the conversion that goes with milligram, okay? So if you go back and look at milli, it says for every 1,000 millis, you're going to have a 1 unit, okay? So for example, for every 1,000 milliliters that you have, that is going to equal 1 gram, okay? So 1 gram per 1,000 milliliters. I'm not milliliters, I'm sorry, milligrams, okay? That's our conversion. We knew we wanted milligrams at the bottom. We know milli is 1,000, and we're going to have 1,000 millis for every 1 unit, okay? So the next thing we want to do is, we have grams at the top now. Now we want to get rid of grams. So we're going to put grams at the bottom, okay? So the next step we're going to take is we're going to go to kilogram, all right? So we know we had gram at the bottom. We know we're trying to get to kilogram. So we know that for every 1 kilo, because we just did this on the last problem, for every 1 kilo, you're going to have 1,000 units of something, okay? We're trying to get rid of grams, so we're going to have 1,000 grams. So we're stopping at kilogram because that's where we're trying to get to. Then we're going to start canceling out our like terms. Boom, 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 boom. We're left with kilogram, is which we wanted. The next thing we're going to do, we're going to multiply across. Then we're going to multiply across the bottom. We're going to get our numbers. 45,456 divided by our big number right here. Oops. Boom. That's what we have. Okay? And yes, you do need to write all of these numbers. All of these are significant figures, in which we'll discuss later on what an actual significant figure is. But all these numbers do need to be written. All right, next we have some practice time. So go ahead and pause this video now and go ahead and work it out, and then come back and check to see that you get the correct answers. Okay, you should have had time to do your work. Now we're here to check. So number 1, you should have gotten 6,100 seconds. Number 2, you should have gotten 0.0859 centigrams. Number 3, you should have gotten 65,400 millimeters, okay? If you are confused how you did this, or you think that you were close but you might have missed a step, please let me know and I can help you with that. I can go over that with you, okay? So now again, it's time to pause and practice. So you will do your practice on page 15. And once you complete page 15, we will go over those answers for your study guide, okay? This is going to conclude our metric system notes and presentation. If you have any questions, please let me know so I can help you.